The first question is, isopropyl cyanide can be obtained by the reaction. In this, look into the option first. Based on the concepts, we know that when we treat it with AgCN, the compound obtained will be isocyanide. So, option A is ruled out and option C is ruled out, because whenever we make them to react with AgCN, we get isocyanide. With potassium cyanide, we get a cyanide group. The product which I am supposed to obtain is isopropyl cyanide, that is CH3, CH and CH3. Here we have a cyanide group, that is CN. So this particular compound we call them to be as a isocyanide. This will be obtained only when you take isopropyl chloride or isopropyl halide. Any halide it can be. It can be a chloride, bromide or iodide. You will make them to react with aqueous potassium cyanide or aqueous, that is CH3, CH and CH3. Here you can take any halide. Since the option is given with bromide, isopropyl bromide, you are going to react it with alcoholic potassium cyanide, so that I will get isocyanide with formation of potassium bromide. So option B would be a correct answer for us. Next one is, which is least reactive towards a nucleophilic substitution reaction? Now, nucleophilic substitution reaction, in the sense the electronegative part should be replaced with that of one more electronegative. Generally, we have two types of hybridization which we are studying under this, that is sp3 hybridization and sp2 hybridization, right? Supposing if you take an alkyl halide, in this particular option A, what has happened is the halide is bonded to sp3 hybridized, but next to that we have a double bond. So the carbocation which is being formed is stabilized. So it will be more reactive. The question is, they are asking for the least reactive. Coming to the next part of it, we have a tertiary group. Since there is a tertiary group, there is a formation of a stable carbocation, that is we get here as CH3 3 times and C with a carbocation. Since we have a stable tertiary carbocation, even the reactivity will be very fast. Coming to the C option. In C option, what exactly has happened is, we have a benzene ring and we have a Cl group here. This particular Cl group has a lone pair of electrons. The lone pair of electrons will get transferred here, and even here the pi bond get transferred to the next carbon, which we generally call it as a delocalization. Here the carbon atom is sp2 hybridized. Moreover, the bond length between the carbon and Cl, when the lone pair of electron is been shifted, what happens is it develops a double bond, right? And then we'll have a negative charge here and we have two alternate double bonds. Since there is a formation of a double bond, what happens is it is very difficult to break the bond. So it will be least reactive. So the option would be chlorobenzene. An alkyl chloride A on reaction with magnesium in dry ether followed by treatment with ethanol gives 2-methyl butane. Give the possible structure of A. Now, according to the question, we are supposed to get 2-methyl butane. The structure for that is CH3C. Second position we have a methyl group and it is a butane. Okay, this is a compound we are supposed to get, 2-methyl butane. Right? If you are very fast, the question maximum it takes you to 1 minute, that's it. Now, we'll start with the first option. The first option is, we have CH3C, Cl, CH3, CH2 and CH3. According to the question, this has been treated with magnesium in presence of dry ether, which we generally call this to be as a Grignard reagent. Preparation of Grignard reagent. So we get the compound as CH3C. Here it will be MgCl, right? And then we get here as CH3, CH2 and CH3. Now this particular compound is treated with ethanol. Ethanol, we have here C2H5OH, right? Ethanol is a very strong base. It ionizes as C2H5 minus and H is plus here, right? So what exactly happens is C2H5O minus will pick up our MgCl group, so that it forms here C2H5O MgCl, right? And then gives me a compound that is CH3C. Since MgCl is being bonded to C2H5O group, the H plus will be substituted here. Here we'll have hydrogen, then CH3 group, CH2 and CH3. The compound what we are expected to get is, I am getting it from A, right? We have an option telling that both A and B. So you need to check even for B now. That is CH3C. We have here CH3, hydrogen, then CH2 group, CH2 and Cl, right? Again, this you will treat this with magnesium. You will treat this with magnesium, where we get a compound CH3C, CH3, hydrogen, CH2, CH2, MgCl, right? Treat this with a base, that is nothing but, according to the question, we are supposed to treat this with ethanol. As in the previous case, here it will be minus, here it will be plus. So when we treat this, we get the same mixture, that is nothing but 2-methyl butane. So what exactly happens is, both option A and B is answering the compound that is 2-methyl butane. So option D would be the correct answer for the question.